Okay, so now circles. So we're going to talk a little, again, circles should be something that, a lot of this is, again, remember it's Algebra 1, Algebra 2, so you've seen this before. So this is just the basics of circles. So circles are, again, by definition, it's a set of points in a plane that are equidistant from a fixed point. That fixed point is called the center of the circle. That distance, that equidistance from the center, is the radius of the circle. Alright, so from the center point to any point on the curve is the same distance, and that distance we call the radius of the circle. Alright, the standard form for a circle equation with the center at the point hk, so h would be the x value, k would be the y value, with the radius r, right? So r would be how far the center is from all the points on my curve, is given by this equation. So again, it is actually the Pythagorean or distance formula, if you want to think about it. It's the distance from my point to my x value squared, the distance from my center point to my y value squared, and then it's that radius, because that's what that is. That gives me that radius squared. As it finds that, again, hypotenuse if you drew it out. And so this is a circle, and so I mean, any point on this curve, I pick any point on this curve, so this is the point I have plotted. Alright. It's exactly our distance from the center. So this is, and so if I picked another point, so if I picked a point over here, it would also be our distance, or picked any point, basically any point on the curve. So the curve is the blue part, that's the circle, and any point on that curve is our distance from that center HK. Circles that land at the center, the formula is a little more simplified. We like circles that land at the center at the origin because it doesn't have the subtraction, because that would be subtracting 0, right? My center would be moving it over here, and I'll draw the picture, so what we mean by the center. So there's my x-axis, there's my y-axis, and so the center is at the origin, right? The origin is at 0, 0. And then every point r distances, the easiest way to draw it is to go r on each of my axes. So this would be distance r in that direction, this would be distance r here. I'd go down r, so that would be a negative r there. I'd go to the left r, and so that would be a negative r there. So if it was 2, this would be 2 in the y direction, 2 in the x direction, negative 2 in the x direction, negative 2 in the y direction. And so plot those points. Usually 4 points are easy to draw your circle, and then there's my circle where my center is at the origin. Any point on this curve would be r units from the origin. So again, any xy on my curve is a distance of r, and so this is the distance formula. Think about it, the distance of r, right? R can be found using the distance formula. The x minus 0 squared plus y minus 0 squared. And that would give me that distance. So the circle is found using the distance formula, and we'll do an example where we'll do that. Alright, first though, we're just going to practice graphing them given an equation. Alright, so the equation actually is down here, landed below my graph for some reason, so I'm going to write up here, x squared plus y squared equals 16. So this is the easy case. This is when my origin is at 0. Alright, so my center is at the origin. My radius is the square root of this number, right? This was the r squared. And so when I want to find the radius, I have to take the square root of that value. And so square root of 16 is 4. So my radius is 4 units. And so to graph this, usually you use 4 points. You graph your center, right? So my center is there at 0, 0. And then 4 units above that to the left and down. So I go 4 up, and so one point on my curve would be the point 0, 4. Another point on my curve would be the point 4, 0. And then down 4, which would be 0, negative 4. And to the left 4 would be over here, negative 4, 0. And then you kind of draw a circle around those. Those are sort of the four points on my curve that makes it easiest to graph. And then you kind of connect the dots and draw a circle, and there's my circle. I pick any point on this curve. My distance, actually I know what that is, it's 4 units from my center 0, 0. Will put me at my xy value. Alright, pick any xy value on this circle, and it's 4 units from the center. Our second example is going to be the other case. So again, for some reason when I put it in my document and made it bigger, it dropped it down here. So I'm going to write my stuff over here. All right, so this is the one I'm going to graph and find my center up. All right, so first the center, remember, is the HK, right? This would be the H, this would be the K. And remember, the hard part about this one is in the original formula, it's x minus h squared plus y minus k squared equals r squared. And so the tricky part about this one is the k value. As it's really, the first one's fine, it's x minus 2 squared, but here I've got a plus. And so what you have to think about is that, well, if I change the plus to a minus, it would be y minus a negative 1. And so the k value is negative 1, right? Because it's the minus case. All right, so make sure you're careful of that. Whenever you've got a plus, it means that number really was a minus, right? Because it's negative is how we get the plus. All right, so the center is the point 2, that's the h value is 2, and the k value negative 1. So the center is at 2, negative 1. My radius, well remember this is r squared, and so my radius would be the square root of that r value, so square root of 9, which is 3. And so when I go to graph it, this is the information I'm going to use to graph it. Alright, so I've got my center, 2, negative 1, my radius is at 3, and so 2, negative 1, so first thing I do is I graph my center, so 2, negative 1 puts me 2, negative 1, there's the center of my circle, and then I'm going to go 3 units above, to the left, to the right, and below this. So I'm just going to count 3. So I'm going to go up 1, 2, 3, and so this point would be on my curve, that would be the point 2, 2, and I'm going to go over 3, 1, 2, 3. That would be at the point 5, negative 1, down 3. That would put me at 2, negative 4, and then back out to the left 3. 1, 2, 3 puts me at the point negative 1, negative 1. There's the 4 points that I'm going to use to graph my circle. And so now you draw a circle between those 4 points. Alright, so there's my circle where the center is at the point 2, negative 1, right? That's 2, negative 1. The radius is 3. Every single point on this curve is 3 units. And again, I use that to graph it, 3 units away from that center. As a distance of 3 units from the center to any point on that curve. Alright, next example. Find the equation of the circles that satisfy one circle, that satisfies the condition, well, has a radius of 1 and a center. So this is at the origin. So it's the x squared plus y squared. X squared plus y squared equals r squared. R is 1, right? And so this is x squared plus y squared equals 1 squared, which is just x squared plus y squared. In case you don't know, that's the unit circle, right? It's centered at the origin with a radius of 1, but that's all we're asked you to find is the circle. Alright, second example. And a lot of times students will do the opposite of what you need to do here. Because it's 25 is a perfect square, they'll say the radius is 5. It's not. It's not 5. When we do our circle, it's x minus our h value squared plus y minus our k value squared equals our radius squared. This is my h value, this is my k value. And so when I plug this in, it's x minus 2 squared, y minus a negative 5 squared, and then it's the radius squared. Well, this is my radius, so it's 25 squared. Students will want to take the square root of that. It's not. It's going to be a much bigger number. It's 25 squared. So if I simplify this, it's x minus 2 squared plus, instead of y minus a negative 5, we write y plus 5 squared. And then you take 25 and squared, and so the radius squared is 625, and there is the final answer to that question. Alright, so again, be careful. Alright, watch out for the squaring the radius and watch out for the negatives. The last example, which is the hardest case, right? The hardest case is if we're not given radius, right? We don't know what the radius, we know what the center is, and we know a point on the curve. Alright, so we know, if I were to graph this, we have the center is at 6, negative 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3. And we know 1 point on the curve. 1 point on the curve is at the point 1, 2. Right, that's it. Alright, so there is the only information I know. That's the center, 6, -3. That's the point on my curve, 1, 2. And so what I don't know is this distance, right? I don't know my radius. I wasn't given the radius. But the radius is just a distance, right? That's a distance, and I have the distance formula. I can solve for the radius, right? The radius is just the distance between the 2 points, right? Which I know how to find the distance between the 2 points. So the radius is going to be the square root of my x2 minus the x1 squared plus the y2 minus the y1 squared, which is the distance formula, right? And then I just plug my points in. Alright, so my x values, so this is, I'm going to let this be my second point, this will be my first point, and so it's going to be 1 minus 6 squared, and then my y values 2 minus a -3 squared. Alright, so we're going to get -5 squared plus a +5 squared, right, plus, and so 25 plus 25, so my radius is the square root of 50. Right, now I know what my radius is. And I'm going to leave it exactly the square root of 50. So I'm going to erase this to give myself a little more room to walk. So I now know radius. Radius is square root of 50. Again, like I said, I'm going to leave it exact. I'm not going to find the approximate. It's an irrational number, and so it's non-terminating, so I'd have to round if I found the approximate. So I don't want to round. I'm going to leave it exactly the square root of 50. And you'll see why once I get to write my circle. Alright, so remember now my circle. Alright, so now the circle. Remember is x minus h squared plus y minus k squared plus r, not plus r, equals r squared. Well, this is the center, so this is my h, this is my k, and now I know what my r is. So I just plug in the parts. So h was 6, so x minus 6 squared. K was a -3, so y minus a -3 squared equals my r squared, so the square root of 50 is r, and then I'm going to square that. And this is why I leave it exactly, because what happens with the square, when I square it, well, it disappears, and so the r squared is just going to turn into 50. And it's going to be exactly 50, so don't round. So the final answer, completely simplified. X minus 6 squared plus y plus 3 squared equals 50 is the simplified equation of that circle. Alright, that has a center at 6, -3, goes through the point 1, 2, and therefore has a radius of the square root of 50. Alright, we will finish there. The very last thing from this set of notes is just practicing how to plot scatter plots and line plots on your calculator. So if you know how to do that, then you might not have to watch the next video, but that's what the next video is on. Alright, we'll stop there with circles though.